into one another. Okay, one into the other, or another into the one. Okay, like for example, so that you'll have a way to remember it, the coffee cup and the donut. Okay, these are homeomorphic shapes. Homeomorphic shapes. The cup is homeomorphic to the donut. The donut is homeomorphic to the cup. Okay. Okay, so now let's say we have a ball, okay, like a basketball. This is our basketball, and we put a rope on the basketball, like the rope. Let's put it in green, so we'll use more colors. Like if we have a rope that goes around, like the equator went around the earth, so we tie a rope, one rope around here, and another rope we tie to here and make it, sorry, and make it go until it meets the rope, this rope in the other side. Okay, so this point in the other side of the basketball that we don't see, we call P prime. Okay, this is P prime, and this is P. The point in the side that we see is P. The point in the side that we don't see is P prime. Okay, and you understand that if we took this basketball and we turned it, remember this is a closed curve. This rope is a closed curve, and this rope is connected to it in 2 points. But we said that the rope is flexible, and in topology, our definitions are also, we don't have to keep, we can't cut the rope, but we can change its shape in the meaning of if we turn the basketball to face us. So this will face us. For example, if we take our basketball, let's draw it here in the end. and we rolled the basketball more to us. So we will see the same rope, this rope, we can paint it like this, okay, right? It was supposed to be on the perimeter, but we can squeeze things. We can make them smaller. In topology, it doesn't matter as long as we don't make holes or cut a line, a straight line. So we can make it smaller, and this, the line that went around the basketball is this line. Okay, it almost goes around, but we made it a little smaller, so we see it here. And the line that was here is here, for example. Okay, and one of the points is P, and the other is P prime. And topologically speaking, this is the same drawing. This and this is the same thing. Okay? We can't make a new connection, but we can move the connections, like we could move the connection to here or here. We can't make this point disappear or make a new point. But what we did here, from here to here, it's okay. It's like a transition that we squeezed it and put it like on a flat surface, on this side of the basketball instead of all around. But it's okay. And we could also make this like a really complicated, like twist it more. Okay, we could take the basketball and really like go crazy with the shape. This is still our basketball. In topology, we don't care if we twisted it or bend it or stretch or squeeze, it's okay. As long as this this shape will still have P and P prime, let's put it here. And also it can be like really distorted, but you understand? These whole three shapes are the same in topology. Of course, this is the most comfortable for us, so we will bring things to this kind of shape, but these are all representations of the same thing, and topologically they are the same. Okay, so in the next time we will continue with Euler's theorem, which talks about how many vertices and how many faces and how many lines a polygon has. And we will use things that we learned now. So thank you. Goodbye.